Graph this equation, identify and label the vertex, axis of symmetry, focus, directrix, and endpoints of the lattice rectum. Okay, so this particular one is not really in the right form. We need to get it in the right form though. So remember in our formulas, we have some variable squared on the left, and on the right we don't have a variable squared, but we do have a variable over there. Here we have a y squared, here we just have an x. Here we have an x squared, here we just have a y. So if you notice in this particular one, our x is going to be squared, right? So let's isolate all the x's on one side and move everything else to the other side. Move both of these over so we end up with a positive 28y and a positive 208. Now we want to complete the square. To complete the square, we take half of b and square it. Half of 8 is 4, and 4 squared is 16. Whatever we do to this side, we have to do to this side. The left side will now factor into x minus 4 all squared. On the right hand side we end up with 28y plus 224. Well, that almost looks like what we're looking for. We have x minus something squared equals all this. What we need to do is see if we can factor out this 28 right here. So let's see if it works. 224 divided by 28. Ooh, it does work. So we have x minus 4 all squared equals 28 times y plus 8. Now if we look back at our formula, that's supposed to be x minus h all squared equals 4p times y minus k. If this is 4p and that's 28, that means p has to be 7, right? So we're going to have x minus 4 squared equals 4 times 7 times y plus 8. That just kind of breaks it up so that we know what all the little pieces are. Here we know that h is going to be 4, p is going to be 7, and k is going to be negative 8. So from all of that, we can get our vertex. Our vertex is hk, so we have 4, negative 8. We are asked to find the axis of symmetry. The axis of symmetry in this case is x minus h. I'm sorry, x equals h. So x is equal to 4. That's our axis of symmetry. We need a focus. Our focus is h and k plus p. Well, h is going to be 4, k is negative 8, p is 7. So we have 4, negative 1 as our focus. We're looking for the directrix. The directrix is going to be y equals k minus p. So y is equal to negative 8 minus 7. Y is equal to negative 15. What else are we missing? The endpoints of the lattice rectum. That's going to be h plus or minus 2p and k plus p. So h is 4, p is 7, k is negative 8, and p is 7. So we're going to have 4 plus or minus 14, negative 1. 4 plus 14 is 18. 4 minus 14 is negative 10. These will be the endpoints of the lattice rectum. So what I'm going to do is count by twos again on this grid and sketch everything as best I can. So first we have the vertex, which is 4, -8. So that'll be 2, 4, 2, 4, 6, 8. So this would be the point 4, -8. Our axis of symmetry is x equals 4. Our focus is 4, -1. So 2, 4, -1. So let's see, let's put that here. 4, -1. Our directrix is y equals -15. So go to y equals -15. 2, 4, 6, 8, 10, 12, 14, 15. So this is where our directrix is going to be. This is y equals -15. And then we have the endpoints of the lattice rectum. So we have 18, -1 and -10, -1. 18, -1, 2, 4, 6, 8, 10, 12, 14, 16, 18, -1. And we have -10, -1. So -10, -1. Now how do we sketch our graph? This is our directrix, this is our vertex, this is our focus. Our parabola goes through these endpoints, around the focus, and away from the directrix. Wow, that one's kind of pretty. There we go.